Hello, everyone, and welcome to today's webinar, Maximizing Assembly Line Capacity with Generative AI, Tools and Case Studies. My name is Elsa Mann, and I'll be your moderator for this session. We're excited to get started today. I just wanted to go through a few housekeeping notes before we begin. This session is being recorded, and we'll share the recording with you afterwards so you can rewatch it at your leisure or share it with the rest of your team. You should also see a Q&A panel on your screen. It should usually be in the center or bottom right of your screen. So feel free to drop in your questions at any time during the presentation. We'll save some time at the end to go through them live. If you do run into any technical issues during the presentation, just let me know in the chat and we'll help you out. In today's webinar, we're going to look at how AI can make time studies, line balancing, and station design faster and easier to carry out, so we can spend less time on manual tasks and more time focusing on making improvements. Now it's my pleasure to introduce our speaker today, Zeeshan Zia, CEO and co-founder of Retrocausal. Zeeshan has led AI projects at Microsoft's HoloLens divisions, Siemens, and more, and he's an inventor on nearly 20 patents. He's also published widely on computer vision and machine learning and has helped bring breakthrough products like Microsoft HoloLens to market. We're excited to have him here today to share how AI is reshaping manufacturing. And with that, I'll hand things over to Zeeshan.
Hi, everyone. Thanks for the introduction, Elsa. Please let me know if you can see my screen when you see my screen. I think you're probably able to do it now. So in today's session, I'm gonna walk you through a couple of case studies and tools that talk about how you can use generative AI on maximizing assembly line productivity. I'm gonna talk a little bit about our product, which is Kaizen Copilot as well, but I don't want to spend the bulk of time just advertising to you. Instead, I'm gonna start out by how you can use open source tools, stuff that's already available out there to improve your processes. So we're going to go through some of the examples of how you can use tools like ChatGPT to improve your assembly lines, and then we will move to more streamlined tools like the Kaizen Copilot that we build at Retrocausal. Elsa was very generous with her introduction. I've spent a lot of time in my career building AI tools, especially focused on frontline workers and with an aim to improve frontline worker productivity. I've also had the opportunity to take a lot of industrial engineering courses and actually spend time on hundreds of assembly lines at this point, helping these manufacturers improve the assembly lines and improve the productivity, quality, and safety of assembly lines. Feel free to put any questions that you have in the chat window during the presentation. I don't want it to be a slideshow, just a slideshow. If you put some questions in there and people vote on those questions, Elsa can then basically stop me in the middle and ask questions, and I'll be more than happy to answer those questions. The slides that you are seeing, they are adapted from our presentation at Automate, the Automate show. Automate is the world's largest, certainly one of the world's largest conferences, exhibitions on automation technology and robotics. And I was an invited speaker there. And the point that I made at my talk there was that at this conference, there's a lot of focus on automating the physical layers of manufacturing. There are tons of robots over here. There are tons of tools to sense things, to do automatic actuation. But there's not enough focus. There's not enough thinking going on the design and implementation layer. How do you design the processes that take place on the factory floor? In fact, the way I think about the manufacturing software stack is imagine you are an auto part manufacturer and OEM comes to you with a CAD model. They say, hey, we need this new kind of glove box made, and you need to produce 200,000 units of this glove box every month starting next month. They'll typically bring the specs of that glove box to that auto part manufacturer as a CAD model, right? It might be AutoCAD, it might be something else. Then the auto part manufacturer might have their own ERP. It might be homegrown, it might be from one of the vendors, Siemens, SAP, you name it. The ERP will typically, again, I'm oversimplifying it, but they will be responsible for uh, pretty much everything that takes place outside the factory, outside the factory floor, right? ERP can do sales and pricing. You can do your suppliers. You can model out your suppliers in the ERP as well. But then there is this big black layer, black hole where everything is still done manually. Your industrial engineers, your continuous improvement engineers, operational excellence engineers, whatever you call them, they will sit down with that CAD model, or maybe they've built a similar product in the past. They will take those, they will try to figure out how to build this new kind of a glove box on their assembly lines. All of that is done on paper. They'll try to figure out the work content. Maybe they'll do a little bit of simulation. They might use stopwatches or a standard like MODAPTs, most MTM, to figure out the time expectations to build that work content. Then they'll design the actual lines. They'll figure out how to break that work content down into work instructions amongst end workers, where they'll have to figure out the workstations themselves. Where do the test equipment go? Where do the bins go? Where do the fixtures go? Then they'll figure out the material handling piece, right? How do we keep these stations supplied with raw materials, with parts from the local warehouse? And then finally, they'll actually make sure that the operators are they train the operators and make sure that the operators are actually following through with the work instructions. All of that today is done on paper. Or maybe you have Excel, maybe you have some tools that are essentially a graphical user interface on top of Excel. There are some great tools out there, right? But often they are 30-year-old tools like Timer Pro, right? Or maybe you've built out your own Excel templates to semi-automate some parts of it, or at least you've tried to make sure that you can standardize this process design and implementation and review process within your organization. Once you've done that, and then by the way, once you've designed it, maybe next month, that automotive OEM comes back to you with a slight modification to that glove box, right? Or there might be some change in demand. So you need to reduce or increase the amount of product you're building, which means you again have to balance the line again and again. All of that is done manually today, or most of that is done manually today. Then you have your MES system, manufacturing execution system, which will take the total work order, in this case, 200,000 units of that glove box. It will take the work instructions and the timings that you designed, and it will schedule the work to the actual operators, right? Operators might have a screen in front of them that tells them, hey, you have to build 1,000 units of this glove box in shift 1, right? And maybe 1,000 units of glove box variant B in the next shift, and so on and so forth. So MES will typically schedule the work by drawing out data from the ERP and all of this work that you did manually. Then you have SCADA and work instructions, which basically control stuff that actually happens on the physical layer. SCADA being all your smart tooling, your PLCs, your barcode scanners, your torque drivers, and so on and so forth. And then finally, you have the actual physical layer where actual work gets done. You have human operators, you have robots, you've designed a certain factory layout to minimize walking time, and so on and so forth. What we've done, or where the industry is heading towards, and where we are trying to take the industry in, is replacing this gray box with an automated layer, at the core of which is going to be a video language model or a multimodal language model. that is able to understand long form video. It's able to understand the inputs from a variety of different kinds of sensors, but it's also able to understand human natural language and process all that data to generate interesting insights. There is a reasoning loop outside of that core language model that the language model can call. For instance, the language model can output a tag that the reasoning loop will read, interpret, and then call external tools. So that basically allows you to take a chat GPT like model, and essentially if chat GPT in the prompt, in the system prompt for chat GPT, we put in, hey, look, if you think there's a need to stop the conveyor belt, send out a tag that we will send, the reasoning loop will send to OPC UA. OPC UA is this universal protocol that a lot of smart tooling speaks. You can send out an OPC UA tag to a conveyor belt to stop it, right? Or the VLM core might ask the reasoning loop to call an external discrete event simulation engine to simulate all counterfactuals. What would happen if that bin were to move closer to the operator? Will that help the operator save 3 seconds every cycle? Or what if we used a fixture on the station to make it simpler to perform these 3 steps? Will that reduce the amount of time that's needed to do this step? Right? The VLM core can talk to all of these things and essentially automate this manual layer. This is where I know this is kind of theoretical at this point. This is the set of tools that we have built out that underlie the tools that we sell, Assembly Copilot, Kaizen Copilot, and Ergo Copilot. But this is also the kinds of tooling that you can build yourself. At least move your Excel sheets towards more and more towards this kind of automation. And that's what I want to talk about in this talk, more than talking about any particular product. Okay. Now, people, again, remember where we started. I was saying that there's a lot of focus on automating the physical layer, on having more and more robots, but not enough on automating or accelerating that design and implementation layer. While it's getting harder and harder to find industrial engineers, young people who go through good engineering programs don't want to join the factory floor, right? So there is more and more work for your continuous improvement teams to perform. And that which is why you want to accelerate some of that stuff. Now, some of the early attempts to at least semi-automate some of the work that continuous improvement engineers do was by building descriptive analytics dashboards. Over the last 15 years or so, a lot of work was done in that space. You have a lot of vendors out there. A lot of manufacturers have built their own homegrown solutions for doing analytics. If you walk pretty much any modern shop floor, you will see these displays which have a lot of numbers on them, which have a lot of charts on them. I'll make a bold and maybe a little bit controversial statement here, but there's a lot of these analytics dashboards have been failures, and the reason they have been failures is because they just describe what's happening on your floor. Oftentimes, industrial engineers or continuous improvement managers, they'll look at them and maybe they track 1 or 2 of those metrics, but that's about it. Really, the challenge is that IEs are always fighting fires on the shop floor. They're trying to do a lot of other things. They don't really have the time to play data scientists, right? They don't have the time to try to understand what's going on, look at all these numbers and arrive at action items by themselves. So what you need to do is more and more moved from descriptive analytics dashboards to prescriptive analytics. That is, can you get directly to action items? What can we actually do practically to improve my line right now, right? That's something that Gen AI enables. And my proposal here in this talk is that, yes, a lot of you probably already have great Excel templates Maybe some of them are macro enabled. There's a lot of automation taking place, happening under the hood in those Excel sheets already. But I would argue that a lot of that automation is in this is descriptive in nature, right? Whereas still there is a lot of workload on the continuous improvement manager to try to figure out, try to decipher all those numbers and figure out what to do. And what Gen AI is enabling you to do is generate action items automatically. And there might even be opportunities for you, so I'm not trying to sell any of our products. Why don't have you considered going into those Excel templates and calling ChatGPT from within those Excels to to make them smarter, right? Can you do better quality, productivity, safety, cost analysis by calling these external LLMs, right? That's what I'll focus the next 15 minutes or so of the talk on. I'll just give you a bunch of examples of using ChatGPT for some of these things. For some of I'm looking at the participants in this call. We have quite a crowd here, pretty exciting. I know some of you people have already been playing with these tools, have already been playing with ChatGPT for a lot of your day-to-day work. So, please hold on if it sounds a little bit boring. Towards the last 15 minutes, I'm gonna get into our tools, right? How we, what's the next step? Yes, you can use ChatGPT to do a lot of these things. It's still unstructured. The next step is, can you use a next-gen application suite like Kaizen Copilot that can bring in that descriptive analytics piece together with the prescriptive analytics piece and accelerate your workflows for time studies, for line balancing, for ergonomics, you name it. I'll keep moving. If there are any questions, please feel free to again put in the chat box, and Elsa will draw my attention to them. Let's start out with ergonomics really quickly. This is a video of a certain operation that's taking place at a factory floor. It's a material handling operation. This lady happens to be a water spider. She's bringing in certain parts to a station. The operator is on the other side. And you can see that she's lifting something that's relatively heavy, and she's bending and she's going in and putting things above her shoulder level, and she's also having to bend in and put them in there. And a little bit later, so she just went in there. A little bit later, what she has to do is she has to drag this whole cart behind her, and there's a twist on her trunk. So this is this IP hood garnish process at a real manufacturer. Just before performing the Kaizen, they had 4 discomfort cases the year before. There was one musculoskeletal disorder related incident costing the company, that floor, about $21,000. There was a 32-inch horizontal reach, 90 degrees back bend, and so on, right? And what we're going to do is we're going to perform a so-called REBA analysis using just vanilla ChatGPT, right? I'll give you a 30-second intro to what a REBA analysis is. It's an ergonomics specific analysis. Typically, if you are an ergo specialist, or even if you are a production supervisor who doesn't know anything about ergo, but your EHS team might have given you something like this, a worksheet like this. You will look at the operator and you will try to estimate their neck position. If their neck position is between 0 and 20 degrees, you will put in a +1 in the neck score. If their neck is bending more than 20 degrees, you will put in +2. You will locate their trunk position. Is the operator bending more than 60 degrees? If so, you put in +4 here. If the operator is bending between 20 to 60 degrees, you put in +3, and so on and so forth, right? You put in look at their legs angle, the angle on their knees. You put that in here as well. You put in all that data, and at the end, you get a final REBA score, right? Which is, if it's 1, it's negligible risk. If it's 11, more than 11, it's very high risk, and you need to implement a change immediately, right? So this is a standard worksheet that your EHS team might give a production supervisor so that they can look at a certain posture and they can evaluate that posture, because your production supervisor is not an EHS specialist on their own. Now look at what you can do with vanilla ChatGPT. In fact, this is the ChatGPT you had 6 months ago. So what I've done is I've taken a screenshot out of the video that I just showed you, and I'm just calling vanilla ChatGPT, and I'm asking ChatGPT that everybody of you have probably access to. I put that image of that operator, and I said, hey, can you perform a REBA analysis of this posture automatically? And also give me recommendations to improve the process, right? The AI got to work. It basically looked at every single one of those elements. It looked at the trunk of the operator, the neck, the legs, and basically the stuff that we were doing manually in the previous slide, and it automatically figured out the scores for all of these body members, right? And then basically it says, look, this is a high risk situation, and you need to do exactly, and you need to figure out the action automatically. You need to do some kind of an action, right? And these are some of the key observations just from that one frame. And these are some practical improvement recommendations. One touch dolly, that could really eliminate the extreme trunk flexion that's going on, raise the lowest storage level to at least knuckle height. That's going to keep the load within the golden zone. Uh, Add a turntable or swivel top, use lightweight totes, and so on and so forth, right? In fact, the interesting thing is that this customer, that this manufacturer, this is exactly what they did, right? Their EHS team got involved. And so basically, they were not using these tools. The video that I'm showing you is a before video, but they had already thought about this manually, and they tried to figure it out, and they built out a one-touch dolly all on their own. Oh, I think, did my screen sharing stop? I think it did. Okay. So essentially, the customer, these folks actually built out this one-touch dolly. This was the real solution that they came up with for that ergonomics problem. And you can see that this is much easier for the operator, for the material handler, and the cycle time is also reduced significantly. And essentially, the REBA score went from 8 to 10, between 8 and 10. I just showed you one posture and the analysis of one of the postures in that process. There were multiple risky postures. The REBA scores were pretty high. And after they implemented this change, the REBA score went down significantly. And I didn't go into that detail, just want to keep it relatively short. But it's also possible, even with ChatGPT, to get some recommendations for how that to draw a picture of how the appropriate one-touch dolly would look like, right? Those kinds of things. I'll jump into another use case because I know that not everybody here is an EHS specialist. Let's talk about automatic line balancing, right? Line balancing is another use case where a lot of continuous improvement engineers, when they're doing it, it's not like they need to do it every single day, but when they're doing it, it might take them days or sometimes even weeks. Specifically, we have an assembly line at an automotive part manufacturer for that glove box assembly. The line has 5 operators on it, and it's currently producing 86 units per hour. This is the cycle time. This is the line balancing efficiency. A continuous improvement engineer went in and performed the time studies manually on all of these 5 operators. Okay, so that's the problem we're talking about, a line balancing problem. This is data from a real assembly line where they're producing a glove box. There are 5 operators that are working on this line, and the CI engineers went in and conducted a time study. And the target state is now to do 70 units per hour, because the customer demand has changed and you don't want to be producing 86 units per hour because you'll have excess inventory. So what these folks did was they had a standard time study Excel template that they used to use. You can see that there are step names in here. They recorded the mean. They did the time studies manually. They recorded mean time. They recorded the standard deviation. All of that data in this Excel. And this is the Excel that we are going to put into, just again, in this case, vanilla ChatGPT, and see what it can do with this Excel file now. Okay, so I just uploaded that time study into ChatGPT. And I'm telling it, hey, look, this is a time study for an assembly line where we are building these glove boxes. Can you please parse this line and basically get me to that desired future state? Right? Can you calculate the current production volume? Then please rebalance the line for 70 units per hour. Right? What it's able to do is ChatGPT is able to write its own custom code. Right? So in this case, it's writing Python code to extract data out of that Excel. And then it's doing a bunch of other things, right? To basically do what you asked it to do. So this is the current line performance. There are 5 operators. This is the current line cycle time, and this is the output rate. It was in fact able to come up with the current correct number, right? That is in fact what's happening on the line as well. And then it's suggested that we use 1 fewer operator, 4 instead of 5, and that's going to get us to 75 units per hour. And your line balance efficiency is going to be actually higher, right? So that's all it took. I took the time studies, I put it into the tool, and it's telling me something. Essentially, this is that I can extract out now the work instructions or the Yamazumi chart for these 4 operators, but essentially this is what the system is giving me, right? I can tell it to generate a new Excel with the future state Excel. But essentially, now my cycle time is 51 seconds. My line balance efficiency has gone up. I'm running the line with 4 operators and with 70 units per hour, right? Doing something like this might very well have taken me 3, 4, 5 hours, right? As a continuous improvement engineer, but I was literally able to do it in 30 seconds. And similarly, I won't go into too much detail here, but if you are a quality engineer, you could do other things like generate a PFEMA, right? Process failure mode and error analysis completely automatically as well, right? All you might need to do is specify the steps or the operations on that line, and ask ChatGPT, how could this step fail? Record the effect, guess the root cause, and so on and so forth. So essentially, I feed in just the time study Excel, nothing fancy, the Excel that I showed you earlier. And in this case, I'm asking ChatGPT, hey, can you generate a comprehensive PFEMA for it? And again, by the way, keep in mind, I'm not saying that the results that get generated out of these tools are perfect. They're not, right? Especially not today. So there is still a lot of opportunity to go in and improve them, improve the results. But the point is that you can accelerate the workflow for your continuous improvement teams, right? That's the whole point. To do a PFEMA, you might have to bring together a number of stakeholders and have a number of meetings, try to brainstorm what can go wrong in this station or on this process. And then, it might have taken you 2 weeks to do it. In contrast, with AI, with vanilla ChatGPT, again, I'm not asking you to buy something from me, right? What this software is able to do is it's able to give you a PFEMA Excel, right? So you go in, and it's a pretty complete PFEMA that you can then, let me see, where's my next slide? Oops, I think my PowerPoint just crashed. Let me just restart PowerPoint. So the point is, you get a great starting point, and then you can of course still involve team members and take it from there. Let me share my screen. Okay. Please let me know if you have any troubles seeing my screen. Okay. So I just wanted to quickly flash the Excel that got generated out of the chat GPT, right? So chat GPT in this case actually wrote out an Excel, right? Here you can see the individual step names that we had entered. For each step name, there is a potential failure mode that has been generated, potential effects, potential causes, current controls, and what the AI might think, occurrence detection, and those scores might look like, and some recommended actions. So it's a great starting point at which you can get started and then work from there. So so far, my proposal here is I didn't go into everybody has their own Excel templates. I don't want to go, I don't want to go into your specific Excel template and talk. There's not enough time to go into anybody's specific Excel template and then call ChatGPT from within those Excel templates. My message so far, my take-home message so far is continuous improvement teams have been building out these systems, excellent systems, for a long time. They've been Excel based. Every sophisticated manufacturer I've been to, they have their own Excel templates, right? A lot of those Excel templates have multiple sheets in them. Some of those Excel templates have macros in them, and essentially, sometimes really sophisticated macros that have, sometimes VB script and so on, a Visual Basic Code and so on embedded in them. All I'm saying is there is this new set of tools available now in the form of ChatGPT. And again, I'm not a spokesperson for OpenAI. There are other companies out there, Anthropic and so on. You can call their tools to make your existing workflows potentially more expressive. You can accelerate your workflows, save your people more time. That was the key takeaway from this talk so far. Okay. Again, I'm happy to take any questions, but the next thing I want to talk about is Kaizen Copilot. Where does the need for, so Kaizen Copilot is our proprietary tool. We are a software vendor. We sell a bunch of tools. We have Assembly Copilot, Kaizen Copilot, Ergo Copilot, 3 different tools. We have a couple more coming up. The challenge with using vanilla ChatGPT, so this is ChatGPT is fantastic. It still has some challenges, right? For instance, when we were talking about line balancing, right? You cannot really control what ChatGPT gives you to a complete extent. What if that line has some steps that are automated, right? You have some steps that are machine steps. What if you have some steps where there are, you have multiple lines coming, multiple feeder lines coming into the main line, and the rates of production are different, right? To produce a glove box, maybe you need 3 subcomponents for every glove box, and those 3 subcomponents are coming in from a feeder line, right? How do you balance that kind of a line? Or how do you specify other kinds of things? Hey, look, these 3 steps are machine steps, and the operator is typically, while the machine is doing work, the operator starts working on the next unit already, right? How do you specify all of that? That becomes really hard to do with ChatGPT, right? Or how do you tell ChatGPT to output things in your proprietary Excel format, right? Without hiring a big team of software engineers to do all of that for you, right? The PFEMA that we just saw is great. It's a good starting point, but you might have your own Excel template for PFEMAs, right? How do you make sure your data is output in the right format? Similarly with ergonomics, right? You might have your own job hazard analysis that has a bunch of other steps in it. How can you automate all of that? How can you accelerate workflows in that uh, while benefiting from ChatGPT and those kinds of tools? That's where Kaizen Copilot comes in. Kaizen Copilot is a pre-packaged software where we can take your Excel templates, incorporate those into the software, so you will be able to download results in your own format. It's a very GUI-based environment. So not every CI engineer has to go into ChatGPT and start doing experimentation. It gives you a standard workflow uh, to accelerate your standard GUI-based graphical user interface-based workflow that still helps you benefit from ChatGPT while maintaining standards. I'll give you a quick sneak peek into the software, and then we'll get into the formal Q&A session. In fact, I also have a couple of case studies from real customers that have used ChatGPT. But again, the idea is in embedding Gen AI into the design and implementation process and documentation process. I'm going to start an instance of Kaizen Copilot. Can you see my screen where I have Kaizen Copilot? Or let me just share that screen. There's a fantastic comment that I completely agree with in the comment box, which is Kaizen requires people to improve their own processes 100%. The reason we chose the name Kaizen Copilot here is to give people the tools to do things that that maybe they're not trained for sometimes. What's beginning to happen more and more, like I said at the beginning, you have folks more and more young people just don't want to go into manufacturing. A lot of young people don't want to go into manufacturing. You're coming out of a good engineering program, you just don't want to go in. So essentially it's getting harder and harder to keep that knowledge and to scale your processes, right? So how the idea here is, how can you give the ability to anybody to do ergonomics analysis, for instance, right? Without having to have them go through a 3-week training certified training program, right? And especially, how do you do that at scale? You are a paper manufacturer, you have 300 facilities, right, all across the country. Some of those are in real remote areas. Maybe you have a production supervisor. How do you train them to do some of these things? How do you train them to do ergo assessments? And that's the idea, right? We want to give these people the even superior tools so that they can do more and more stuff by themselves and improve these processes by themselves. At the end of the day, the implementation piece has to be done by them. So this is Kaizen Copilot. There are a bunch of different modules here. Kaizen Copilot is primarily based on, sorry, I'm having some troubles with my internet. Kaizen Copilot is primarily based on smartphone video. You can, in fact, see some of that in my background as well. The idea is you capture video of a process, you put it into Kaizen Copilot, and the software can then do things for you. For instance, the time study piece, when I talked about line balancing, I kind of skimmed over how we got that time study, right? Time study can be a tedious task. Just doing a time study on a station, let's say you want to capture 20 cycles of a process for statistical meaningfulness, and you got 20 cycles of that glove box process, and in each cycle there are 20 operations, right? So 20 cycles times 20 operations is 400 operations. If you're trying to manually do that with a stopwatch and a clipboard, you're trying to note things down, and then the operator moves on to the next step and you kind of lost that data point. if you record a video and then you sit on a video editor, then you have to manually, label 400 steps. In contrast, just one of the things that Kaizen Copilot allows you to do is you just upload a video, and then the software can break down that video into meaningful assembly steps. So you specify one of the cycles in the software. You say, look, this is the cycle that I'm interested in by moving the slider. And the software detected the rest of the cycles in this video. This video, I happen to have just 3 cycles. So the software automatically detected the rest of the cycles, first of all. And then it went in and it broke down those cycles into meaningful steps. In this case, 14 assembly steps. I'll wait for it to load for a bit. And on the top right, you can see how that process was broken down into those cycles, into those steps, right? So the AI automatically broke it down into steps that basically would be pretty salient, right? And it did so across cycles. So you get the same consistent process across cycles. Step names get defined automatically. And as you do more and more time studies in Kaizen Copilot, the step names become more and more contextual. They become more and more relevant to you. The software can figure out whether it's a value add step, non-value add step, or necessary but non-value add step. It's got a completely graphical user interface that allows you to, again, compare groups of cycles as well. Morning shift cycles versus my evening shift cycles. How is the operator doing across those? Again, it's calling ChatGPT-like feature. We have our own proprietary language models. We're not calling ChatGPT. Your data stays within your cloud, but you get all these benefits of using a generative AI model, and you can get really, really rich Excel sheet templates as well. So some of them are default, they're by default, but if you give us your Excel templates, we can onboard those into the tool also. I'll just give you a peek at this one. So again, what the software has done is, in this case, let's say you had those 400 operations or 20 cycles of 20 operations each. You just uploaded the video, and the software essentially breaks it down and conducts the full-time study for you that you can then download in a variety of Excel templates, including your existing Excel templates. And then it can go in and it can actually generate improvement recommendations as well for every single one of the steps. So here, this is an operation. Again, I've renamed some of these steps. I use this account to demo the software to potential customers as well. Here you see that the operator, what he did was he went in and he picked up that part and brought it to the fixture, right? And the software says, hey, could you just shorten these distances for advantage? Could you be using a contact grasp rather than a pickup grasp? Or could a power tool be employed, right? Similarly, here it says, could parts be slid across the work surface rather than carried above the work surface, right? So it's coming up with all these improvement ideas that might be relevant. Could both hands be used simultaneously with one hand reaching for the tool and the other hand reaching for a component? It's able to understand video content as well as step names, and it's giving you all these recommendations that you can say yes or no to. And then in the final screen, it consolidates all those improvement recommendations for the station. It gives you things like spaghetti diagrams of how the operator's hands are moving. But based on prior data, it also gives you its estimates of how much cycle time you can reduce. If you shorten distances for advantage, if you move that bin from down there to somewhere closer, you might be able to save as much as 1.9 seconds in cycle time. If you optimize reach distances by organizing frequently used tools closer to their point of use, you might save as much as 4.5 seconds per cycle. If you used a better power tool, you could save 3.5 seconds and so on, right? Quickly, in station layout suggestions, it understands that this is your station layout. It calculates the amount of work that's taking place in each of these zones. So 7.7% of work happens in zone 4, which is back there. Kind of the operator has to stretch out their arm to pick up parts from there, and the software is telling you, hey, you should use move some of those bins closer to the operator, and that will save you 2.4 seconds in cycle time. Right? So that's just the station level things. You have then, again, I don't want to go into too much detail, and I'll go into the Q&A section in just 2 more minutes. But you can do more complicated things as well. For instance, this is a line balance, automatic line balance example. All I did here was I imported a bunch of station design examples. So it's in station design, I conduct the time studies. I go into line balance to actually balance the line. This is my current line. The number of bottleneck station is station 3. You're producing 21 parts per hour. Your operator 1 is overburdened, blah, blah, blah. And I think I've assigned all the works to one operator. I could say, okay, rebalance it to 3 operators. And the software will basically rebalance the work for 3 operators now. Again, I can generate a variety of Excels. It can also handle things like machine steps. So in this case, when I set this up, this particular step is a machine step. And you can see that this is an SWCT chart. This step is being performed in parallel to some of the other work, but that step is not. For that step, the operator actually has to wait, right? And again, you can download these results in a variety of formats and such. I'll just flash the ergonomics piece for you for just 1 second, and then we'll head to the Q&A section. Similarly, for ergonomics, the software provides a standard user interface and it can process videos, which ChatGPT cannot. So we took that whole process that you were seeing earlier. The AI is breaking down the operator's body joints into angles, into 3D angles. It understands that there are these 2 risky postures. This is one risky posture. It has a REBA score of 9. This is another risky posture. It has a REBA score of 7. And for these, it can generate these improvement recommendations, such as rotation of the lower back. Here, the operator is basically rotating her upper body differently from her lower back, whereas this is the right way to do it. If you see here, the operator was basically dragging this cart, and there was a twist at her trunk. And you can see a bunch of other kinds of analysis. The software has broken down your video into static stance, static standing stance. There is power zone, there is stupor lift, there is free motion. So it's taken your time, on the x-axis, you see the seconds, on the y-axis, you see the activity. And of course, you can just take all of this as either Excel sheets or as PDFs. You can take this to your operators and show them, look, this is what you're doing wrong, and you need to improve something here. Okay, bunch of other things as well that I won't go into, such as you can actually go in and the software can actually analyze movements on your shop floor as well. It can help you figure out better shop floor layouts, for instance. So this is a certain shop floor where operators are walking around, and I'm generating a spaghetti diagram of all the operator movements. So here you see a lot of different operators walking around in an environment. And then the software, in fact, let me just pull up a simpler example so I can actually give you something more meaningful in the next 10 seconds. What the software did here was there were 2 operators that are walking around that are doing a certain packaging operation. The software says, look, this is a better layout for your cell, because the operator has to walk all the way back there move that supply closet closer to here. And that's going to reduce your walking time from 75 feet to 63 feet per cycle. Right? It's figured out the route for each operator and so on and so forth. I'll pause here. I understand that there are a bunch of questions potentially and so on. I'm happy to answer those and so on.
Good. Thank you, Zeeshan, for walking us through all those examples and insights and just ideas to kind of use what tools we already have, such as ChatGPT, to really elevate the type of work that we currently do and save time. We do have a bunch of questions that come in, so we'll do our best to get to all of them in the time that we have left. Please do continue dropping your questions in the Q&A window of your screen. If we don't get to your question during this time, we'll definitely follow up and reply you over email. So the first question that we have is, how accurate is the tool in executing all steps of the process for line balancing and ergonomic posture assessment? And it's two parts. Also, what precautions should engineers take to ensure the analysis is reliable and no critical steps are missed?
Those are great questions. For line balancing, essentially, line balancing is, you see all the results. So it's not just vanilla ChatGPT. In the case of line balancing, you can download a variety of Excels where it shows you every step of the operation that it took to arrive at the conclusion that you're seeing. So it's basically perfect. It's completely accurate. It's actually doing things based in a mathematical way, as opposed to, in the case of line balancing, it's not just generating text out of thin air. There's actually another question while I'm on line balancing. How does the Copilot take into account the precedence of different processes and constraints as well? You can specify all of those in the within the software user interface of the software. Similarly, with ergonomics, it's basically there is a study that we performed working with the University of Waterloo in Canada with their EHS department. And what they found in that study, there's a peer-reviewed paper that's coming out in a couple of months. What they found, so they used our tool. They also took a lot of humans and human-based measurements. They also used some wearable sensors, and they found that these computer vision-based tools are significantly more accurate than human measurements. So visual measurements alone, they're on par with the accuracy that you would get out of wearable tools. So, wearable sensors and such. So basically all you have to do in this case, you're chasing an operator with a smartphone, and the software gives you the same kind of accuracy as if you had to go through all that setup, put wearable sensors, some gloves, some other things on the operator's body. So that it's pretty accurate. It's actually a lot more accurate than as compared to just a human. And again, to answer Ganesh's question, you can specify predecessor relationships in here, as well as specify other kinds of constraints. So I can say that step number 10 really requires, and again, my apologies for step names and such. So I use this account also for customer demos, and sometimes I'll randomly rename steps and such. But so here I just said to start step 10, step 9 should be completed, but also step 2 needs to be completed. And I can say that this step really needs to be done on this station because there's a tool that lives on this station. So you can certainly specify those kinds of constraints within the tool, precedence constraints and such. Here's the precedence diagram, and I think actually I just forgot what did I I think I said that step number 10 requires step number 2 as well as step number 9. So you can see that the precedence diagram is here, and when you rebalance it, of course it's going to respect those precedence relationships.
Perfect. The next question is, what are the video recording requirements to ensure the tool receives the correct input for SOP creation, VLM, such as camera angle, resolution, lighting, and overall quality?
Fantastic question. So it's pretty lax. You can use pretty much any mobile phone. You don't even have to install any kind of app on that mobile phone. You just record a video, you go back to your computer, log on to kaizencopilot.com and upload the video, and that's all you need. It can, but it's camera agnostic. So if you do happen to have cameras that are mounted on ceilings or walls, you can use the video feed from those cameras as well. But yes, absolutely, most users use smartphone cameras to use the software. There are a couple of, again, it's pretty flexible. Uh, you want to, for line balance and station design and a floor analysis or cell layout analysis, you want to keep the camera relatively static. The camera shouldn't be moving. Typically, people will use a magnetic mount to mount the camera. Although people have used the software even on completely moving lines, moving assembly lines. I can talk more about those, and where entire cars are coming down the line, or there is an engine that's moving across the line and operators are following it and doing work on them. uh, but ideally you want to keep the camera relatively static. For the ergonomics, of course, you chase the operator around. Lighting is not really that big a problem, but so again, it's pretty flexible, really.
Good. I am getting some questions around whether or not the presentation will be available later. And yes, we'll be sharing both the slides and the recording afterwards. So don't worry if you didn't catch all of that. So the next question is, if you save a sufficient number of seconds from two nearby stations, will the tool recommend a relayout that combines the two stations into one?
That's a good question. Yes. So if you absolutely. So in line balancing, it is able to basically combine stations together and those kinds of things.
Perfect. And I'm just conscious of time. I think we might have time for one more. This question is, I think, referring to the spaghetti diagrams that you had on during the station design portion. So spaghetti diagrams, is of complete body movements or arm movement?
Yeah, so we can do both within the software. Typically, when you're doing the floor analysis, then it's then the software is doing complete body movements. When it's a station level, you can choose to just do hand level movements. For instance, for benchtop assembly. So the software can do both. I think the one that I showed earlier was of hand movements, and the one that I showed towards the end was a full body movement.
Perfect. All right, I think we have time for one more question. I'll squeeze one more in. How much is the accuracy of Kaizen Copilot in solving the assembly line problems in real life?
Yeah, that's a great question. So again, the line balancing piece, that is, in fact, the line balancing piece to provide you with some improvement recommendations as text, it calls an LLM engine, but otherwise it's just doing operation, OR algorithms, operations research algorithms. It's actually running numbers. So it's 100% accurate. And it's showing you all of its workings as well. So you can download all the results uh, as Excel. Of course, there might be things that you just cannot model in the system. For instance, hey, look, if right now I have 5 stations, after the line balancing, I will have 3, and there will be some, based on how you actually lay out your station. Maybe you're saying maybe I have the same operator working 2 of those stations. How do you get the walking time, right? Unless you can put the walking time precisely, unless you can actually measure it for the new line, the system can only work with assumptions, right? So there, you might need to actually put in the correct time, right? But otherwise, to the extent that you've conducted a time study using those times and using those standard deviations, it's going to be 100% accurate.
I think makes sense. Well, I think that's all the time we have today. I want to keep everyone on time. I want to thank you again, Zeeshan, today for sharing your time and expertise. And thank you everyone for taking time out of your day and spending an hour with us. Again, a quick reminder, today's session was recorded and we'll be sharing the link with you afterwards so you can share it with your colleagues or rewatch it. Also, when this webinar window ends, you should see a short survey. They'll ask for your feedback and what types of topics you'd like to hear next time. So we love to hear your thoughts about what insights you took away and what you'd like to hear more about next time. If you would like to learn more about Retrocausal or any of the AI tools that you saw today, please visit us at retrocausal.ai or shoot us an email at demo@retrocausal.ai, and we'll be happy to chat. So thanks again for your time today. We look forward to staying connected, and we hope to see you in a future webinar. Have a great rest of your day.
Thanks, everyone. Bye.